Hello, hello, and welcome back, everybody. Today we're going to continue working on our metrics within Kubernetes setup. So yeah, yesterday we actually managed to make it work. So we deployed a Prometheus instance into our Kubernetes cluster, and we managed to make it actually collect metrics from our server applications. So actually that was just for the gateways. We would need to figure out how to do that for other applications as well. But yeah, today we need to actually make it work properly, because that was just some experiments. So, let me see, where do we start? So I already started my Minikube. I also need the dashboards. So there we go. So we have Prometheus running in the default namespace. Yeah, we need to move it to the to what? To the, how was that called? Not metrics. I don't remember. Do I still have the documentation pages that I used yesterday? Well, somewhat. Monitoring, that was the namespace. Yeah, I was using this thing. Hello, Aninia. Good morning. How are you doing? Hello, hello. So yeah, we were using this thing, Prometheus community, Helm charts. At least I think we did. Crap, maybe not. I don't recognize this readme file. Maybe. Yeah, this readme looks different from what we used. Crap, what did they use? What Helm chart did they deploy? I don't think it was this one. Kube Prometheus stack. Yes, this one. Okay, so this is a part of the Prometheus community Helm charts. I see. So yeah, we were using this. So let's do what? Helm uninstall. Prometheus. That was the release name, I think. Yes, okay. So we uninstalled Prometheus from the default namespace. Now I want to move it to the monitoring namespace. So we're gonna do this. Release name Prometheus. Namespace monitoring. Is it working? It's been very slow. Okay, yes, it is working. There we go. Grafana should come up in a minute. Another thing that I was thinking is on the actual production cluster, I would actually like to avoid installing Prometheus directly in the cluster that's running the game server. I mean, I could if I deploy this cluster across both of my servers, but I want to keep it in one. So I don't know. Or maybe I use one server as a control plane with Prometheus, and the other one's gonna be just for the game. Not sure. But if I can, I would probably prefer to configure it so an external Prometheus collects the metrics from the game servers, and then maybe we can make it work that what was that? Which component was that? Not operator. Adapter. So Prometheus adapter, I think I saw that we can configure it in a way that it's connecting to an external Kubernetes server. So maybe I can install Prometheus adapter within the cluster that grabs the metrics from external Kubernetes server and exposes them to the Kubernetes cluster itself. So then I can use those metrics to do autoscaling. I don't know. Yeah, Prometheus URL. So maybe I can configure this thing somehow that it's going to connect to the external Prometheus, and then we can configure it that it only exports specific metrics, not everything. Because my Prometheus that I'm currently using in production, it actually collects a lot of information from different parts of the Ymirheim ecosystem. So, what do we do here? So I want, yeah, I need Grafana. So this is going to be our Grafana password encoded in base64. It's something very simple, but I don't remember what it is. Yeah, Prom operator, Prometheus operator. So now we need to grab the pod name for Grafana, and we need to forward the port. Okay. Okay, this is our Grafana. Okay, good. Now, let's see, do we already have our metrics? Yes. So it's already scraping all the metrics that we need. The problem is it's only doing that for gateway servers because this was what we configured for now, because other servers run that on different ports and we didn't forward those ports yet. So that's one thing. Another thing is we don't have the labels that I need. Wait, what is this service? Gateway default. Okay, so this is a nice label, but what I need is more granular stuff. What is the instance? I see. Endpoint, container. So yeah, I need to figure out how to add labels here. So let's see. Need to Google that. Service monitor. OpenShift documentation? Or is it this thing? Is it actually called labels? Let me see. Let me check my Prometheus, like standalone Prometheus configuration. Where was it? Where is my music? Where is it gone? Ah, okay. Prometheus, target. Yeah, those are called labels. So how can I add custom labels to the endpoint or to the service monitor? Honor labels, metric relabelings. Replace, keep, drop. Oh. Replace. Map, keep, lowercase, uppercase. Huh. Modulus. Metric relabelings. Relabelings. Like, how can I add a label? Job label. Label limit. Target labels. Items type string. Type array. Target labels. I don't think this is what I need. Job label, just a string. Like, I need a key value pair. I need to add a key value pair. Add label to matrix. Utilizing Prometheus operator and keep Prometheus stack chart. additional relabelings. Please don't tell me it's not implemented. No, this is not it. Wait. I'm currently using the Prometheus operator and Prometheus stack charts. Currently have about 120 service monitors in each clusters. We import all the metrics from those clusters to a central global Mimir cluster. Currently use the external label parameter. External label. I don't see it here. To add the cluster ID label to all the metrics, and this works fine. External labels. Where the hell is this defined? This is not it. I guess that's relabelings. So should I use the replace to add? Looks like it. So yeah, that's on the endpoint. Relabelings. Target label. So what do we need? What did I use? AppNV. This is the environment name. This. Okay, what else? App name. That's called type. Yes, that's type. And app kind, but now it's gonna be called app ID. But for now, let's keep it app kind. Actually, what we can do is we can do both. And that's ID. So we can support all the dashboards that I have that rely on app kind and app ID. So hopefully this is enough. So now what we do, I need a separate terminal. Helm update upgrade like that. So now if we go to wait. How is that working? Because now it should be in a different namespace, right? Or maybe that's just all the data in there, because the namespace should match what we have. It's monitoring, right? Yes. Hello, 𝙽𝙴𝚁𝙀. Hi. Okay, it's here. So we have the relay blends. So it should theoretically work, right? And the release should match the release. So I need to make this configurable, and the overall service monitors should also be an option to enable or disable. But okay, it should work. It should now export the metrics. So if we reload this, login connections, there it is. App env staging, app kind default, also app ID should be default. What else do we have? App kind, app name. Wait, env, ID, and name. Name gateway. That's all that we add. Env, name kind, and ID, yeah. Okay. And we have the data. Nice. Okay, so we figured out that. That's really good. Yeah, now we need to make all this thing configurable. So, to do that, first I think I need to add ports, the metrics ports for every project. So to do that, not project, but every instance. Let's do that. Ports. So we add ports for the login server. So login, login listens for the metrics by default on 6903. Now Vault 6904 and zones 6905. Okay, so now we have the metrics ports. That's good. Now what? We can make it dynamic actually. Like right now it's defined in each config file. Sometimes it's not. All right. This thing needs to be different. Okay. So it shouldn't be the global configuration. We actually should configure it manually in the deployment. So for that, what do we need? I think we need to add configuration here. Metrics true. Do we need to set a port or something? No, I don't think so. So metrics true. Maybe we can have something like metrics port 6901 by default. Yes. So metrics true, metrics, wait. Expose metrics true, metrics port. These are going to be our two new settings. So for this, and this expose metrics can be used here as well. So if we have exposed metrics, that will create the service monitor. So we also need a global service monitor. So enabled or not, first of all. Then we need the namespace. We need release, no, labels. Wait, how do we do this? Like this. This should be values, system monitor, labels. Okay, value system monitor labels. Now we can get rid of this. Namespace. Okay, so if system manager is enabled, then we do that. Actually, let's put it before the range. So we have the name, namespace, have custom labels, match labels, that's good, port metrics. Let's also add relabelings. Wait, is this how they called? Yes, I guess. Something like that. Okay, should be good. Hello, doll. Hope you're doing good. Okay, this, I want this to be conditional. So this is gonna be app labels. Now, append app labels. True. Okay, so this will add these labels. Then we have customer labelings. And we have our namespace and labels configured. Should be good. So now here, expose metrics and metrics port. Yeah, that's back to the deployment. So that means here in the port, what we can do is container metrics port default 6901. Wait, something's wrong. How do you do this again? Weird. Why it's not highlighted? I don't know. Okay. Metrics port. Now here, what I want to add is if we have expose metrics default true, then we add two config options. So what we need is monitoring Prometheus enabled true, and scrape endpoints monitoring Prometheus scrape endpoints. That should look like this. And it should be metrics port. So is this enough? Expose metrics, metrics port. Oh, also in the service, we need to do the same. So we only expose metrics. It actually can be the same for every type. Just only if we have expose metrics enabled. And this should be the metrics port. Oh, that also means here when we define the metrics port, we can do it right here. And also have it conditional only if we expose matrix. Here, expose matrix. Wait, that's liveness probe. Oh no. Okay, so then we cannot do that. We actually have to define that here. Guess we define ports in every single thing and liveness probe together. But okay, that's fine. So this will override our config file settings. So this means we can get rid of this. We can get rid of this. Okay. That's everything. So if expose matrix, we also expose the matrix part on the service. And that points to the deployment. In deployment, we have the matrix port always defined. That's okay. Even if that's disabled, it just means that the port is not being listened by anything. Then if expose matrix is true, default is true, we enable Prometheus and have scrape endpoints defined. Then in the service monitor, if service monitor here is enabled, we configure the namespace, labels for each instance, have append labels and custom relabelings. Okay, that should be it. So let's uninstall. Also, what's the default setting? Should be disabled by default. Let's see. It's not here. It's in here. Core monitoring Prometheus. Enable exporter. Yeah, it's false by default. Okay, good. 𝙽𝙴𝚁𝙀. Why is... Okay, whatever. Okay, so it should be good. So we uninstalled our... Wait, what? Ah, okay. So this is Prometheus. And default namespace is empty. So now we install template failed, service monitor YAML, value system monitor enabled. Oh, not system monitor, service monitor. Oops. Still, it's null. Oh, that app. Now what's wrong? Value. $11. Okay. So now if we go to monitoring, we should have custom resource system service monitor. Okay, now we have a bunch of those. So for example, login. Let's see. Okay, release Prometheus. Namespace monitoring. Endpoints port metrics. We have the relabelings. Custom label. Okay, looks good. So login, for example, now we should have different endpoints exposed and services. Gateways, metrics, vaults. Okay. So looks like it's running. So if I add I don't have anything. Do I need to reload? Interesting. Something's wrong. Let's see, is this thing present? Monitoring Prometheus enabled, true. Scrape endpoints 6901. So it should be good. Have the matrix. Where did I see the endpoints? Like an actual link to the endpoints somewhere. Here. Oh wait, the IP address now should be different in Minikube. Minikube IP. It's constantly changing. It's stupid. Probably I need to install Kubernetes cluster properly on my dev machine. Okay, so I have the metrics here. I wonder if I do that for the login server and do the metrics port like that. Would that work? Yeah. So I should have the Boulder Wolds matrix available. And I don't see it. Also, I don't see any new data. So the data stopped coming in. So monitoring namespace. Custom resource definition, service monitor, gateway. That was working before, now it's not. So release Prometheus in the labels. Yeah. Namespace monitoring. So it should be Prometheus operator, right? There was a documentation page about troubleshooting. This one. So let's see. And as my app namespace selector, I need this. So spec namespace selector spec namespace selector match names. So how can I get the namespace in there from Helm? But let's see, is this everything? So this in OpenShift monitoring. So metadata labels, match labels. That is empty, but we have actually not empty. It's like it needs the release Prometheus. Then here namespace selector match names, selector match labels. That should match with this thing, with this service. Okay. So probably this is what's going on. This is why we don't have the data. So let's see if this helps. Actually, I could have just done an upgrade. So I added this namespace selector, match names, default. How do I export Prometheus dashboard again? Proxy it. Right. Ah. Prometheus 0. So I need to export that. The same way I do this. Thank you, 1990. That was our previous port. No, not Alert Manager, Prometheus. Okay, so it should work. Should see some data. Okay, the data is coming in now. That's good. So now if we add another query, there we go. Now we have a lot of statistics. So let's see, for example, NPCs registered. How do I trigger run query? There we go. 2.6, 2.1, 1.5K, 583. So this 583, this is on what? On towns, okay. This is 2 on what? Gateway. Ah, that's the login connections. We combine the graphs now. Okay. This is dungeons, fields, fields. Okay, perfect. So now I need to figure out how to pull the current namespace that Helm installs into. So Helm current namespace. Built-in objects. Release namespace. Okay, so this should be this.release.namespace. Perfect. Perfect. Okay, so we have the service monitor configured actually properly. We have metrics ports exposed. We have expose metrics is configurable, and metrics port is configurable. Okay. Let's see, what else do they want to do with this? Automatic metrics scrape and work, yes. Custom labels, yes. I actually want to try and see. Wait, let's move this tab into here. Actually, I don't need it. So this is good now. We have the data coming in. I want to see if I can import my dashboard. Import Let's see. Grafana, provisioning, dashboards, Balder, zone. Hello? Oh, it needs a URL. Oh, wait. Import. Let's run with the environment. Settings. Where do I define data sources? Boulder players online. Job Boulder. Job Boulder. Wait, what is this? Prometheus, Boulder, targets. Release. Ah. Job Boulder. Yeah, we don't have that anymore. It's different now. So this should be app name. Where is app name? Oh, there it is. App name Vault. No. Yeah, I guess we just delete this. Yeah, previously I was tying to job Boulder, but yeah, now we don't have that. Save. Staging. Oh no. I think this also, yeah, this also ties to job Boulder. I need to get rid of all of that. What's going on? Why don't I have any data? App name zone, app environment, app environment. Ah. Where is the run queries button again? Run queries. Okay, this doesn't work. Weird, but okay, we'll figure that out in a moment. Where is run queries? Here. Back. No, data. Character worker pool update time. Yeah, there's something wrong with the Histograms. Looks like they're broken now. Peak update time. Wait, this should be correct. It's not working. Yeah, histograms are not working. Why? So the metric is there. No, it's not there. Milliseconds bucket. Millisec. Why is it now called milliseconds? Why not ms? Why? But okay, milliseconds, bucket count, sum. Wait, this is weird. Interesting. So it's definitely something being done by OpenTelemetry. It was a mess, now it's milliseconds. Weird, but okay, I can just update my dashboard, no problem. So let's see. Let's test on the NPC worker pool. That one should have plenty of data. So job boulder and milliseconds, run queries. There we go. That's our histogram. Weird. There we go. There is our data. Okay, this needs to be gone. Let's also change this to last 30 minutes so we can see some fresh data. Okay. So yeah, unfortunately, I will have to update my dashboards, which means I can get rid of app kind. But actually, I don't think I'm using that. Actually, I do. But okay. Wait. Run queries. Okay, save dashboard. Right, so that's cool. We have our dashboard with all the data that we interested in, but that's only for the zone server. Right. Okay. Let's see other dashboards. New, import, world. Hello? Import. Okay, so let's edit settings, variables. Yeah, let's get rid of job. Oops. Variables, job. Yeah, app kind. Well, for now, that should do it. So staging, world ID, asker, key. Well, status now data. Why? Again, because of the job. Need to get rid of that. Good. Okay. Oh, we have one more panel. Okay, and exit edit. Show last 1 hour. Wait, what? It didn't save. No, it did. What? What? Why did it break? Stage and ask. Ah, okay. I didn't select the environment. Okay, so that works. That works. Okay, now another one, new Boulder login. Import, edit, settings, variables, job. Okay, should be good. Staging, last 1 hour. Okay, good. We have our login dashboard, and now the last one, gateway. Edit settings, variables, we get rid of this. Back to dashboard, staging, edit. One more panel. Okay, save, exit. Okay, we have our dashboards. Nice, really, really nice. Why is this in red? Probably because my Minikube is very small virtual machine. Okay. The histogram looks a little weird, to be honest, but that's okay. That's okay. At least we have the data, so yeah, now I need these dashboards back. So let's start with the gateway, export as JSON, download. Where do I put it? Let's just put it here for now. Login, export. World, export. And zone. All right. 48 milliseconds. Interesting. Maybe there is something wrong, I don't know. That shouldn't happen. I mean, that's peak. The average is about 1.5 milliseconds. But yeah, this is concerning. But yeah, probably it's just Minikube is way too small. So what if I do Minikube SSH? I can't. Minikube SSH. Do they have htop? Yes, they do. Well, yeah, it's extremely small. I'm almost out of memory. Well, not almost, I still have 2 gigabytes. But yeah, CPU is pretty much overloaded. But that's okay. It just means that we are running a lot of stuff in there on just 2 cores. Okay, so we have the dashboards. Yes, let's do that. Let me actually put those dashboards somewhere that I don't forget about them. Okay. Right, so now one sec, I want them to be in a separate folder. Okay. So we have that. Okay, so now I think we're done with this. So we are done with exporting or like fetching the metrics from the application into Prometheus, but they are not yet available in Kubernetes, right? To do that, what do we need? We need this one, Prometheus adapter. It already should be there as a part of our Prometheus deployment with the Helm chart, but we need to configure this, right? Where do I start with this even? Config file. Let's see, is it covered with this? So, have the service monitors. Shut up. I hate these things. Annoying. Mute. Okay, we have that. Yeah, this article doesn't cover anything about that. So we're done with that. I don't need this anymore. So maybe we can commit what we have already. By the way, I don't need this anymore. This is default. Service monitor. This can be commented out. Not minikube, wait. Template, okay, good. So yeah, I guess we can commit what we have here into the repository. What is this again? This is something that I did yesterday. Yeah, I was just unifying the settings, I guess. Okay, so let's push that. So what did we do here? Expose matrix. Now we automatically configure Prometheus. We add the matrix port. That's good. We added that to the service. Good. Service monitor. Yeah, now we have the service monitor templates, and we have new values. So this is service monitor support for the Kubernetes setup to export app metrics to Prometheus. Okay. So we've done that. So yeah, now I would like to export some Prometheus metrics back into Kubernetes cluster itself. Okay. So how do I do this? Docs. Config walkthrough. Full walkthrough. So prerequisites, cluster configuration. Before getting started, ensure that the main components of your cluster are configured for auto-scaling and custom metrics. As of Kubernetes 1.7, this enables the aggregation layer on the API server. What's that? And configuring the controller manager to use the metrics APIs via their REST clients. What is that? Tailings instructions can be found in the Kubernetes documentation under horizontal pod autoscaling. Maybe we can assume that this is done, and if it doesn't work, then we come back to this article. Because I don't want to read all of this. This is enabled by default. So container resource metrics, scaling and custom metrics. I guess I need this, right? So configured for auto-scaling and custom metrics. So it's stable. That is not built into the Kubernetes or any Kubernetes component. The horizontal pod autoscaler controller then queries this custom. I don't know. I don't know. We assume for now that this is done and this is configured. Properly configured metrics server or enabling custom metrics autoscaling support will disable CPU autoscaling support. Don't really care about that for now. Now that most of the API versions in this walkthrough target Kubernetes 1. Okay, we're running basically the latest version. We don't care. We have our Prometheus operator. Okay, the scenario. Suppose that, oh, okay, so this is the article that I was reading yesterday, and This is actually where we... No. It just looks similar. Okay. Or maybe it is one of those articles that we were reading yesterday, but okay. Suppose that you've written some new web application. Yeah, this is definitely something that I've read before. And, you know, yes. Thankfully, look at Kubernetes. So we have the application. It has the HTTP port exposed. Check your app. So yeah, it works. Now you'll want to make sure you can autoscale your application on that metric so that you've already that you're ready for your launch. You can use horizontal pod autoscaler like this to accomplish the autoscaling. Horizontal pod autoscaler. Scale target to ref. Point the HPA to the sample application you've created above. Okay, so this is our deployment basically. Autoscale between 1 and 10. Metrics. Use the pods metric, which takes the average of the given metric across all pods controlled by autoscaling target. HTTP requests. So type pods. Use a pods metric, which takes the average of the given metric across all pods controlled by the autoscaling target. I don't know. If you try creating that now and take a look at your controller manager logs, you'll see that the horizontal pod autoscaler controller is attempting to fetch metrics from this thing. But right now, nothing's serving that API. Before you can autoscale your application, you'll need to make sure that Kubernetes can read the metrics that your application exposes. So launching Prometheus, we have Prometheus. We are monitoring our application. We have the service monitor. Sure. Now you should see your metrics appear in your Prometheus instance. Yes, we have the metrics. Look them up via dashboard and make sure to have the namespace and pod labels. Let's take a look. So which one? Namespace and pod. Namespace, default, pod. Nice. So we have that. If not, check the labels on the service monitor, match the ones on the Prometheus CRD. Okay. So we have that, that's working. One sec. Launching the adapter. So I do have the adapter apparently running inside here. Actually, maybe not. Wait, where is it? Maybe it's some kind of custom resource. I don't know. how can I check if it's running? Config map. So config map, adapter config. Where is it? Config map. Oh. Huh. I don't have the adapter running. Interesting. So let's read this thing. Now that you've got a running copy of Prometheus that's monitoring your application, you'll need to deploy the adapter, which knows how to communicate with both Kubernetes and Prometheus, acting as a translator between the two. The deploy manifest directory contains the appropriate files for creating the Kubernetes objects to deploy the adapter. See the deployment README for more information about the steps to deploy the adapter. Let me check. Manifests. Deployment. So yeah, I should have Prometheus adapter, and I don't have it. Interesting. What's going on here? What? Look at it go. It's getting crazy. But okay, I have Grafana, operator, and state metrics. What are the state metrics? Kube state metrics. The simple service that listens to the Kubernetes API server and generates metrics about the state of the objects. It's not focused on the health of the individual Kubernetes components, but rather on the health of the various objects inside, such as deployments, nodes, and pods. Okay, it's nothing to do with Prometheus. So we don't have the agent. Why? We should have it. Adapter, I mean. Okay, Helm charts. Prometheus stack. Prometheus adapter. Wait, the stack provides resource metrics by deploying the Prometheus adapter. This adapter is an extension API server. Kubernetes needs to have this feature enabled. Otherwise, the adapter has no effect, but still deployed. It's not deployed. It's not deployed for some reason. What? This chart was formerly named Prometheus Operator Chart, now renamed to more clearly reflect that it installs the Kube Prometheus project stack, within which Prometheus Operator is only one component. The chart does not install all components of Kube Prometheus, notably excluding the Prometheus adapter and Prometheus Black Box Explorer. Why? Why? Guess we have Helm charts for adapter. Installs the Prometheus adapter for the custom metrics API. Custom metrics are used in Kubernetes by horizontal pod autoscalers to scale workloads based upon your own metric pulled from an external metrics provider like Prometheus. This chart complements metrics server chart that provides resource-only metrics. Configuration. So I should have the repo, right? This is the same repository. Right, as usual, have a lot of options. Prometheus. So yeah, technically I should probably be able to deploy only this thing and point it to a different Prometheus URL. Rules. I would need to change this, right? But okay, we install that. To use the chart, ensure the Prometheus URL and Prometheus port are configured with the Prometheus service endpoint. If Prometheus is exposed under HTTPS, the host CA bundle must be exposed. Yeah. Adapter rules. So additionally, the chart comes with a set of default rules out of the box, but they may pull in too many requests, pull in too many metrics, or not map them correctly or for your needs. Therefore, it is recommended to populate rules custom with a list of rules. See the config document for the proper format. Horizontal pod autoscaler metrics. Finally, to configure the horizontal pod autoscaler, to use the custom metric, use the custom metric section, HPA walkthrough. That's the official documentation. The Prometheus adapter can serve 3 different metrics APIs. Custom metrics. Enabling this option will cause custom metrics to be served at this endpoint. Enabled by default when rules default is true. Rules default true. But can be customized by populating rules custom. I don't understand what this means. Rules resources template. External metrics. Enabling this option will cause external metrics to be served at that endpoint and can be enabled by populating rules external. Resource metrics. By enabling this option will cause resource metrics to be served. That endpoint resource metrics will allow pod CPU and memory metrics to be used in horizontal pod autoscaler, as well as the kubectl top command. Oh, is that a thing? I don't think I've ever seen it. Huh. Interesting. Nice. Now setting a value for rules resource, we'll also deploy the resource metrics API service, providing the same functionality as metrics server. As such, it is not possible to deploy them both in the same cluster. Okay. So, the default rules. The chart also comes with a set of default rules out of the box, but they may pull in too many metrics or not map them correctly for your needs. Therefore, it is recommended to populate rules custom with a list of rules. Well, let's try the default rules. I don't know. Yeah, let's try with the default enabled. So what do we need? We can just try and install the chart. So this is gonna be Prometheus adapter. I need it to be in the namespace monitoring. Okay. In a few minutes, you should be able to list metrics by using the following commands. Thank you for that. Currently unable to handle the request. Okay, so I need to wait for it. What's wrong with this memory chart? This is ridiculous. It's kind of nuts. But okay. This should theoretically be working. Okay, so right now we don't have anything. In a few minutes, you should be able to list metrics using the following command. Well, right now they're empty. But okay, let's get back to our thing. Where is the article I was reading with the best application in the world? This one. So theoretically, we have an adapter. We don't have custom rules, but hopefully the default ones will pull the metrics that we're interested in. I don't know. So this adaptive configuration should work for this walkthrough together with a standard Prometheus operator configuration. But if you've got custom relabeling rules or your labels above aren't exactly namespace and pod, you may need to edit the configuration in the config map. Where do they use pod and namespace? Namespace. Weird, I didn't see any metrics. Double checking your work. With that all set, your custom metrics API should show up in discovery by fetching the discover information for it. APIs custom metrics K8s IO v1 beta 1 beta 2 not found. That's a little bit weird, but okay. Since you've set up Prometheus to collect your app's metrics, you should see paths HTTP requests resources show up. There's a present the HTTP. Okay, so we don't have that. So yeah, I guess I have to define my custom rules. The default ones are not working. It's empty. That means that I would have to redefine the values. So serious query. Serious. Label matchers. I don't understand the resources template. Okay, serious query. This basically selects all the metrics that have namespace not empty. Name that doesn't match container something. It should be underscore total, should be ending by underscore total. This is really weird. But okay. The problem is I don't think it's possible to like deploy a custom thing, custom entity into Kubernetes cluster that handles the configuration for my specific thing. For my specific application. Like we did with the service monitor to define the metrics to scrape. It's not possible to define something like this to pull metrics from Prometheus into Kubernetes. For this specific app, I have to do a global configuration like this. Why default rules are not working? That's concerning me the most. Wait, maybe I need a namespace. Metrics. No, not metrics, monitoring. Interesting. Okay, one thing that I don't remember is when a Helm chart depends on other Helm charts. I don't remember how that works specifically. Wait, what is this? Prometheus adapter. Custom metrics. Name. Some metric count. What is this? Name matches empty string as my custom metric. What? I wish I could define that as a separate object, not globally for the whole adapter. The adapter determines which metrics to expose and how to expose them through a set of discovery rules. Each rule is executed independently, so make sure that your rules are mutually exclusive, and specifies each of the steps the adapter needs to take to expose a metric to the API. Each rule can be broken down into roughly 4 parts. Discovery, which specifies how the adapter should find all Prometheus metrics for this rule. Association, which specifies how the adapter should determine which Kubernetes resources a particular metric is associated with. Naming, which specifies how the adapter should expose the metric in the custom metrics API. Querying, which specifies how a request for a particular metric on one or more Kubernetes objects should be turned into a query to Prometheus. Sample config. Each rule represents some naming and discovery. Okay. This rule matches cumulative 𝙽𝙴𝚁𝙀 metrics measured in seconds. This rule matches against 𝙽𝙀. Must return only a single metric family. Okay. This metric will appear as 𝙽𝙴𝚁𝙀 in the custom metrics API. Name as 𝙽𝙴𝚁𝙀. Okay. Resources overrides. This should still resolve in our cluster. Group resource. What? Resources. Skip specifying generic resource label mapping and then just, I don't know. Skip specifying generic resource to label mappings and just attach only pod and namespace resources by mapping label names to group resources. Specify that the container underscore and underscore seconds total suffixes should be removed. This also introduces an implicit filter on specific family names. We use the value of the capture group implicitly as the API name. We could also implicitly write it as $1. Specify how to construct the query to fetch samples for given series. This is a Go template where the .series and .label matchers string values are available, and the delimiters are that, and avoid conflicts with the Prometheus query language. To avoid conflicts with the Prometheus query language. Some rate queries label matchers. I don't know. So discovery, this is clear to me. This is okay. I understand that we select certain metrics, certain groups. Association. This association governs the resource of process. Oh my god, I cannot read anymore. Figuring out which Kubernetes resources a particular metric could be attached to. The resources field controls this process. There are two ways to associate resources with particular metric. So yeah, resource, let's say it's our pod, right? In both cases, the value of the label becomes the name of the particular object. Name of the particular object. The value of the label. What label? Any label cube group resources. Group resources becomes group.resources in Kubernetes. What? One way to specify that any label name matches some particular pattern refers to some group resource based on the label name. The other way is to specify that some particular label represents some particular Kubernetes resource. Overrides field. Each provides maps to a Prometheus label. Right. Each override maps a Prometheus label to a Kubernetes group resource. What is group? Is it like the type of the resource, like pod, for example? Apps deployment resource. Group apps resource deployment. I don't understand this. These two can be combined, so you can specify about the template. Okay. Naming governs the process of converting Prometheus metric name into a metric in the custom metrics API and vice versa. It's controlled by the name field. Naming is controlled by specifying a pattern . I think I should just play with this and see what happens, because I have absolutely zero idea. So raid by 2 minutes. We get some of that. But I don't know. I need to see it in action. So to do that, let's create a file. Prometheus. How is it called? Adapter. Prometheus adapter.values.yaml. So I need to copy that rules custom. So default false, because they don't work anyway. What's wrong with this? Block sequence may not be used as an implicit map key. What? Ah. So let's try to find a metric that we can experiment with. What can we use? I need something more or less dynamic that I can play with. Players online users vault status. Zone instances, zone servers. Could do the client connections on the gateway server side. Where the run query command. So yeah, let's do that. How can I copy the name? Oh my god. Okay, let's do this. But wait, this will also be tied to a pod, right? Let's see. So I have the pod, and those are different for each pod instance. What metric can I use here? And it's something tied to a pod. Maybe not. Maybe I shouldn't tie that to a pod, but have some kind of global state. So yeah, like all the sum of all client connections. So here I have two of these things. Can I code some of this thing? Run query. Now I have just one. So if sum of all client connections across all gateway servers, so name equals that name Boulder network client connections And let's try to just deploy that. Did they have, they did have some kind of example for one specific metric. Somewhere at the end here. So we have that as this, yes. Still, I don't understand this thing. What is group? What is resource? Metrics query. Oh, it's already a sum. Oh, and yeah, by the way, I could not do that. So yeah, this thing. So where is our install? Let's do upgrade that thing minus f this. Okay, now will it return me anything? Unable to update list of all metrics, unable to fetch metrics for query container. So that was, yeah, it was just now. The hell? Wait, it's gone. Adapter. Unable to fetch list of all metrics, unable to fetch metrics for query. Aha. It can't connect to Prometheus. Prometheus default SVC. So we need to set the Prometheus URL. Doesn't know it, cannot discover it. But okay, sure. I thought it would be more how do you say it? More intelligent. So what is the Prometheus service URL? Prometheus. Wait, what? Which one do I forward? Prometheus, Prometheus, Cube, Prometheus, Prometheus. It's this one. Prometheus, Cube, Prometheus, Prometheus. But okay, it looks like this is the service name. So let's do that. Upgrade. Let's see if that helped. So that was 57. Oh. Interesting. Okay, what if I enable default? So wait. What was the error? Unable to update list of all metrics. Unable to fetch metrics. Lookup Prometheus. This is still talking to the default Prometheus URL. Oh, okay. I guess I need to find this again. Recreate. Okay. Oh, I do have something. Can I prettify the JSON? JSON path file. What if I don't do raw? Will it show me something? No. Like, is there a way to transform the JSON into like a human-friendly format in here? JSON YAML. What if I do JSON? Raw. Was it output? Yeah. Raw and output are mutually exclusive. Server print true. No, doesn't help. Guess we just use the raw thing. And just use some online converters for this. Okay, so what do we have? Resources, pods. Jobs, batch, services, namespace. What? But okay, what if we... Oh, the default is enabled. So this is with the default. It just doesn't know how to do anything with the default rules. What if I get rid of custom? Oh, we have something. So yeah, I guess if I define custom, the default, again, oh my god, this is a lot. Okay. Okay, we have a lot of things. Yeah, I don't need any of that. But yeah, basically it exports everything, I guess. Qpod status scheduled. Okay, boulder entities, signal queue size count. So it does export my metrics as well. Players online. And services. Namespaces. But yeah, it gets added to like namespaces, pods, jobs, batch, and services. Every single one of the metrics. Jobs, batch, services, namespaces, pods. So yeah, basically the same thing that I did here. It does basically for every metric in Kubernetes if you use the default rules. So let's not do that. Let's define the custom rules. So does that mean that I can use multiple instances of this Prometheus adapter per each application, let's say? So if I'm deploying my Ymirheim server, I can deploy this Prometheus adapter alongside with it and configure the metrics that I want to see. I guess so. Okay, if we care only about this, then let's deploy that. Yeah, it's gonna take a little while before it deploys. So one thing that I wanted to see, because I don't remember how that works, I only briefly touched it, is how we can do child charts in Helm. Chart types, application and library. This is something new. This is the default type and the standard chart, which can be operated on fully. The library chart provides utilities or functions for the chart builder. Okay. Chart dependencies. In Helm, one chart may depend on any number of other charts. These dependencies can be dynamically linked using the dependencies field in the chart YAML or brought into the charts directory and managed manually. Managing dependencies with the dependencies field. Okay. So yeah, I can add something. Okay. Once you have defined dependencies, you can run Helm dependency update, and it will use your dependency file to download all the specified charts into your charts directory. Okay. Let's try to do that. So if I use something like this, dependencies fields in the chart dependencies. So I would like to have a dependency on Prometheus adapter. Prometheus adapter. From this repository, what's the version? Where can I see the version? I mean, I can look it up here. Like that. Okay, so now I have that thing in the charts That's actually a gzip file. But okay, we have that. When Helm dependency update retrieves chars, it will store them as chart archives in the chars directory. So the example above, one would expect to see the following files in the chars directory. ls field in the dependencies. In addition to the other fields above, each requirement may contain an option field alias. Chart would put a chart in dependencies using ls as a name of new dependency. Okay, so I can basically reuse the same chart with different names. What? In addition to the other fields above, each requirement may contain fields, tags, and conditional chars allowed by default. Condition tags. Guess there's supposed to be another heading, but they missed it. So yeah, I'm interested in this. In the above example, all charts with the tag front end will be disabled, but since the chart when enabled, path evaluates to true. Subchart 1 enable. Importing child values via dependencies. In some cases, it is desirable to allow child charts values to propagate to the parent chart and be shared common defaults. No, I don't want that. So how do I reconfigure the child chart? Like if I want to override settings for the child chart, do I just include the values in my values file with that name, with the chart name? Helm chart templates written to the Go template in the Go template language. Predefined values, no. Value files. Consider the template previous value files. So this is just value files in general. I need to see how can I override the default values of the dependent chart. Value files can declare values for the top level chart as well as any of the charts that are included in the charts directory. Or to phrase it differently, a values file can supply values to the chart as well as to any of its dependencies. Okay. The values file could supply values to all of 3 components. Okay. Chars at a higher level have access to all of the variables defined beneath. So the WordPress chart can access MySQL passwords. Okay, good. Values are namespaced, but namespace is a print. Okay. Global values. Okay, so that means that I can... Well, first of all, we were in the middle of something. Whoops. Hopefully it didn't go through. Yeah, so our Prometheus adapter now exposes these metrics, but I guess now I can Helm uninstall Prometheus adapter from the namespace monitoring. That's uninstalled. And then I can, since I have my, where is it? I can copy this to here under Prometheus adapter name. Let's see if I can make it enabled false. Will that disable the Prometheus adapter completely? So let's see if I... Now, where am I? So Helm, template. That's my thing. Ymirheim server. That means that I can also do the same with the Postgres. I can just bundle the chart. Or put it into the dependencies, I mean. Oh. So it's not working. So what was with that enable thing? One sec. So yeah, that's the Prometheus adapter deployment. Where is the config file for it? testdb app service. It's mixed. That, I guess... No, that's config map. Have a bunch of those. Wait, why? Oh, I guess we have a separate one. Yeah, we have a separate one per each thing. Sure. Prometheus adapter config map. That's our config. That's our custom roles. Okay. So what was that with
developers?
developers.
Yes!
Yes. Hello, SKN, I didn't notice you. Hi. Yes. Yeah. I really like how it says that. Tax and conditions. So let's see. Subchart 1 can I see. Okay, so that means that they can put that into here. So Prometheus adapter enabled. Why is global there? Subchart 2 enabled. Global subchart 2 enabled. Why is there 2 of this thing? How's the project going? It's going slowly, but yeah, these, like, I am trying to figure out metrics and how to set them up properly for my application in Kubernetes. And yeah, it's challenging. These things aren't like straightforward, and documentation is weird at times. But at least we have some documentation. We have actually a lot of documentation. It's just yeah, I need to get used to that and read a lot of stuff. So now if I do this, it should get rid of this Prometheus adapter. Let's also comment out most of these instances. So app service monitor, testdb, app deployment, testdb service, app service, app config map, service account. Okay, so now it's gone. And if I set it to enabled true, default false, this should create the other files. Yeah, there it is. Prometheus adapter, custom metrics API service, testdb deployment, app deployment, Prometheus adapter deployment, testdb service, app service, Prometheus adapter service, Prometheus adapter role binding auth reader. Okay, roles. Yeah, that's another thing that they need to figure out. I don't remember how roles work. Probably I need to set up RBAC or however it's called. I don't know. App config map. Prometheus adapter config map. Yeah, these are our custom roles. Service account. Okay. So this should do it, right? Helm upgrade. Wait, I forgot to uncomment my instances. So upgrade YH dot failed. Cluster APs invalid value none. and it changed once set. Interesting. But okay, we can uninstall. And then install it from scratch. Okay. So now it should be gone from the monitoring. There should be no adapters. Okay. And now if we switch to default namespace, there it is. Prometheus adapter. Okay. So this is actually good. That means that I can fully control it. It's just it's weird that I'll have a separate deployment of Prometheus adapter. But I guess that's totally fine. Probably this is why it's not bundled with the default Prometheus chart. So okay, now we have this metric. Now I need to figure out how to work with it. Where was the command to check if we have the metrics? Here. And it's empty. Oh no. So we don't have it. Pods, Prometheus adapter. Unable to update. Prometheus, cube, Prometheus is not there. Okay, so how do I connect to my Prometheus in the other namespace? I assume this is because this adapter is now in a different namespace. So, Kubernetes, DNS, different namespace. Okay, so this should be monitoring.svc cluster local. Maybe that will work. Can we upgrade? So nothing so far. Maybe this is a dead pod. I have no idea. But I don't see any errors now. So hopefully, yes, now we have our metrics. Okay, so this works. Now we have our metrics inside Kubernetes. Now, where is the walkthrough? This is the one, right? No, this is for the adapter. I lost that thing. Oh my god, where was that article? Okay, so definitely don't need this. Metrics discovery and configuration. This is not the article that I'm looking for. Sample config, I don't need that. This is not this. This is the one, right? Yes, this is the one. So we have our application, we have adapter, now it's running. Still, I'm a little bit not sure about how we configure all of that. It seems very confusing to me, but okay. So we also need to register the custom metrics API with the API aggregator, part of the main Kubernetes API server. For that, we need to create an API service resource. Do we need that? I guess so. The API is registered as custom metrics. I think I already have that. Yeah, double check your work. So yeah, now we are right on here. We managed to actually get the metrics. Since you set up your metrics to collect your app's metrics, you should see pod HTTP request, but in our case, that's namespaces, services, pods, Boulder Network Client Connections. Resource show up. This represents the metric converted to a rate aggregated to have one data point per pod. Notice that this translates to the same API that our horizontal pod autoscaler was trying to use above. You can check the value of the metric using get, which sends the raw request. Okay, let's try to do that. But we need to change the metric name to this selector app sample app. I see. So for selector, we would need, let's see, gateway. Do we have any? No, I need a pod. What if I don't specify the selector? Could not find. Because of the adapter configuration, the cumulative metric has been converted into a rate metric on the HTTP requests. Like one thing could be that the uppercase may not be handled correctly. But let's still try with that. How can I set the selector? Oh, I think it's because it shouldn't be beta 2, it should be beta 1. There we go. So, kind metric value list. I would like to see it in a proper format. So let's see, describe the object, pod, that's our pod, metric name, timestamp value 0. Okay. And just in case, I want to see if it changes if I connect to the server. Wait, what was the server AP? This. Okay. So I'm connected right now. Let's see. Let's take a look at Prometheus and run the query. Yeah, now I have one connection. Let's do over the last 15 minutes. So yeah, we have one connection. What do we have in the metrics? So value 0, value 0. Value 0, value 1. Nice. So yeah, the gateway server actually but this is per gateway server. So now because I'm connected to this gateway server instance, we have two. I have value 1 there, but the other one has value 0. But if I would like to rely on a metric, like the total value across all the gateway servers, I guess I would need to do this differently. So probably I need to remove the group by or something. But okay, let's see. Maybe I can do that in... I don't know, to be honest. Like what I'm trying to do is scale the gateway servers based on the amount of client connections. So if we have like, let's say if we have 0 connections, it should be just one gateway server. If we have 1 connection, it should scale to 2 gateway servers. Something like that. So how can I do that? But okay, we have the metric. It's actually running. Let me mute this thing a sec. Okay, so we now actually have metrics inside Kubernetes. Now we can proceed. Quantity values. Notice that the API uses Kubernetes-style quantities to describe metric values. These quantities use suffixes instead of decimal points. Yeah, I don't care about this. I have integers at this moment. Missing metrics, we have everything. So autoscaler, now that you have finally have the metrics API set up, your horizontal pod autoscaler should be able to fetch the appropriate metric and make decisions based on it. If you don't create a horizontal pod above, create it now. Okay, so let's get back to that horizontal pod autoscaler, this one. Let's see, so what does it do? It references the deployment. Good, so we can reference our gateway server, for example. Autoscale metrics type pods. Oh, what if I request a metric, not pods, but name spaces? Or should I do... How do I do this? Use a pods matrix which takes the average of the given metric across all pods controlled by the autoscaling target. That's average. I need to read about this thing. So what we're looking for again? Metrics type pods. Type percent. Like, what are the other options? Type pods. Resource pods object. Oh my god. Why is this in German? English, this. Ah, it's this article. Custom metrics. I have no idea. Where is that article again? So metrics pods, metric name, pods HTTP requests. But there was something else. There was namespaces. I don't know. It doesn't make any sense. Wait, what? Oh, that's v2. Yeah, I don't know how this works. But okay, target value, average value. I don't need the average value. But okay, what do we do with this? So let's do new file, app-hpa YAML. Let's copy this file. So, yeah, let's include all of that. So this is gateway HPA, for example. Okay, what else do I need here? Target reference, deployment name. Deployment name. Ah, crap. Okay. So let's do then this thing. So for every app, we do this. Wait, let's just copy it. Okay, also I want the condition to be only for the gateway for now, while we're testing. Okay, now what? I need to reference the deployment. So the deployment name is this. Apps v1, yes. To scale between 1 and 2 replicas. Pods metric name is, oops, this one. So target value shouldn't be average value. I need a specific value. I don't know how this works. Aha. Wait. Can I see all the options available? Like if I want type value, second alternative metric is the object matrix. This describe object in the same namespace instead of describing pods. I have no idea. Type value and value, I don't know, 1? What does that indicate? So I have matrix, right? Target value 1. What does that mean? How can I assign, like, that I want max replicas to be a target value? So what does this one do? The scale and deployment. Target CPU utilization percentage field has been replaced with an array called matrix. The CPU utilization metric is a resource metric, since it is represented as a percentage of a resource specified in pod containers. That is that you can specify other resource metrics besides CPU. By default, the only other supported resource metric is memory. Instead of percentages on there, by using target type average value instead of utilization, setting the corresponding average value. So the pod metrics, these metrics describe pods and average together across pods and compared with a target value to determine the replica count. So how does that work? They work much like resource metrics, so that they only support a target of average value. I need to read this from the beginning, I guess. Okay, so I have a server, and that server is running, create an autoscaler using kubectl command. You will shortly run a command that creates a horizontal pod autoscaler that maintains between 1 and 10 replicas of the pods controlled by PHP Apache deployment that you created in the first step of these instructions. Roughly speaking, the HPA controller We'll increase and decrease the number of replicas by updating the deployment to maintain the average CPU utilization across all pods of 50%. What? So it tries to scale based on the status until the status is met or what? Roughly speaking, the controller will increase and decrease the number of replicas to maintain the average CPU utilization across all pods. And then the replica set either adds or removes pods based on the change to its spec. Since each pod requests 200 millicores, this means that average CPU usage is 100 millicores. What? So we increase the load. So target is 50, current is 305. Then more replicas, 7. As a result, the deployment was increased to 7 replicas. How did that get calculated? 305 divided by 50, 6.1. So it creates 7 replicas. So that's the target value. Aha. So in this case, this would mean, like average value, if I do 1, for example. Let's say we have one gateway server, right? If we have one client connected to it, that would mean that it will have just one replica. If we have 2, that means that we don't meet the target. It's above the target. So it will try to create another one. So then the average is gonna be 1. This is weird. How can I create something more simpler? Like we have total amount of players connected, right? There should be a login server metric for that. Even on the dashboard. Login, vaults, gateway connections. Users connected by vault. There's Boulder users connected, app name login. And we don't care about the vault, for example, right? Vault 1, vault 2, wait. This is weird. Total. I think something was wrong. But okay. This is weird. See how that autoscaler reacts to increased load. To do this, you'll start a different pod to act as a client. The container with the client pod runs in an infinite loop, sending queries to the PHP Apache service. Within a minute or so, you should see the higher CPU load and then more replicas. Here, CPU consumption has increased to 305% of the request. As a result, the deployment was sized to 7 replicas. You should see the replica count matching the figure from the horizontal pod autoscaler. Stop generating load. And the deployment shows that it's scaled down. Once CPU utilization dropped to 0, the HPA automatically scaled the number of replicas back to 1. Scaling the replicas may take a few minutes. Scaling on multiple metrics and custom metrics. You can introduce additional metrics to use when autoscaling deployment. First, get YAML. Okay. So we have that. Metrics resource, CPU, target CPU utilization, average 50%. Status. You can also specify resource metrics in terms of different values instead of percentages of the requested value, by using a target type average value instead of utilization. There are two other types of metrics, both of which are considered custom metrics: pod metrics and object metrics. These metrics may have names which are cluster specific and require more advanced cluster monitoring setup. The first of these alternative metrics types is pod metrics. These metrics describe pods and are averaged together across pods and compared with a target value to determine the replica count, compared with a target value. They work much like resource metrics, except they only support a target type of average value. Okay. The second alternative metric type is object metrics. These metrics describe a different object in the same namespace instead of describing pods. These metrics are not necessarily fetched from the object, they only describe it. Object metrics support target types of both value and average value. With value, the target is compared directly to the returned metric from the API. At average value, the value returned from the custom metrics API is divided by the number of pods before being compared to the target. The following example is the YAML representation of the request per second metric. Described object. This uses target type value but average value. Described object If you provide multiple such metric blocks, the horizontal pod autoscaler will consider each metric in turn. I think I'm trying to do something that will never be the case. So let's say we have users connected, right? So I wanted to maybe create a autoscaler that will increase the amount of gateway servers based on the users connected to the login server. I don't think it's actually useful. Like, I can actually use this average, this pods type, and this is actually the metrics, the metric that comes from the gateway server, which indicates the number of client connections. So I can, if I say here our average value should be one client per a gateway server. That means if I have one gateway server and I connect one client, that should be still fine. If I connect the second client, that will go above this average value. And it will scale to 2, and then the average will become 1. I see. So yeah, this should be fine. Use a path metric which takes the average of the given metric across all paths controlled by the autoscaling target. Yes. So this should be good. And let's increase that to, I don't know, 3. Maximum 3 gateway servers. So if we deploy this, I'm pretty sure it will work. Error credential YAML to JSON line 21. Right. Why is it? Stupid thing. So here we have 2 spaces, 2 spaces. Here we have some weird problem. Probably. Wait, target type value. Pods. Wait. Something's wrong. It should be like this. Target type. Why? Where is that thing? Let's replace the metrics. Average value 1. Oh, I think I know what happened. I tried to do this, and then it went south. Okay. So let's see what happens. Gateway default. Replica set. 2 pods. Oh, I think I know. I need to remove... I can delete this file. So this thing is preferred now, I guess. Let's comment it out. Also, I should see... How can I see the... Okay. Run in 1, desired 1. So, wait. Run in 2, desired 2. Is this because I'm currently connected? Let's see if I disconnect. How can I... What do they do to describe the status? Get HPA. So that should be deployment job spots, replica sets, replication controllers. No. Services, config storage, cluster. How can I get that HPA in the dashboard? Okay, target 01. Replicas 2. Target 0 of 1. And we have 2 replicas. Why? Horizontal pod autoscalers. 1 to 3. Where is the status? Why do we have 2 right now? That's the question. Replica set. Weird. So I commented this out. Max replicas 3, average value should be 1. So right now, the value is 0. The target is 1. Why did it create 2 replicas? Okay, I'm gonna connect and let's see what happens. Okay, so I can see my connection. Now replicas 1. I mean, what? So it's scaled down. have just one pod now. Which is interesting. But okay. What if I connect the second client? One sec. So a second client is connected. Let's see if it updates. Come on. I mean, the watch thing is not very reliable. But here I cannot see the actual status otherwise. Okay, so we have 2 out of 1. So it should create another replica, right? It should be 2 now. Yes. Okay, so it works. Not sure why this was a thing. Why it created 2 replicas. Maybe that was like an initial state that it tries to like keep when it doesn't have any data, but I don't know. It looks weird. But okay. Now I have 1 client. Actually, didn't mean to do that. No, wait, there should be 2. There should be 2 clients. Oh, I guess now the average is 1. Yes, yes, yes. Okay, good. So now the average is 1. Target is 1. And we have 2 replicas. So now if I connect a third client, one sec. Uh-oh, what's happening? My monitor is going crazy. Oh no. Uh-oh. Okay, the game crashed. But yeah, that was to be expected, I guess. One second. So it shows 500 M, I guess 500 milli something. So 0.5, it should be 0.5. But okay, I just connected another one. One second. Let's connect a third one. Okay, so now we have 3 connections. So at the moment we have 2 replicas. This is weird, but yeah, we have 1.5 out of 1 targets. And it created the third one. Okay, good. So now if I close, one second, let me double check that it's actually, yeah, it's 3. And we have 3 gateways. That's interesting. So now if I... Where's this thing? So now if I exit from let's say the first client, let's see what happens. Okay, so now it's still 1 out of 1. Come on. Okay, 666 out of 1. Sure. So will it downscale? I guess the downscaling will take a lot of time. It should be like that. Because, yeah. They actually did say something about that. Create, increase load, stop generating load. Verify, the output is similar. Let the CPU utilization drop to 0, HPA automatically scale and our replicas back to 1. Auto scaling the replicas may take a few minutes. Okay, it's still 666 out of 3. But okay, maybe it considers it a good result. I don't know. Let's exit from another one. So now I have just one client running. So now it should be 333 out of 1 with 3 replicas. Come on. Why it's not working? I wish I could see the state of the HPA. I can only see min and max and reference. Weird, really weird. Okay, so now it's 333. Will it scale down? It's not scaling down. Interesting why. But yeah, it actually works. At least that's good. It did scale down one time, so we had 2 replicas. As soon as I connected the first client, for some reason it scaled down. I guess it was not calculating anything when the value was 0 or something like that. I don't know. But yeah, it's not trying to scale down right now for some reason. But yeah, it actually works. That's important. At the moment, I have no idea how we can dynamically configure this. I don't know. It's not scaling down. So let's see. So value 0, and then this one value 1. There should be 3. Is it 2 now? 3. Still 3. What changed? No, 16 minutes changed. So there should be 3 pods. Value 0. Value 0. And value 1. So yeah. I'm only connected to one gateway right now. Oh, it did scale down. It did remove one gateway. Nice. Okay, it works. It works. It works. Probably it will just take a while before it scales down, which makes total sense. It's actually how it's supposed to work. It should be configurable somewhere, but I guess it's going to be a pain to find the actual config options for that, because this documentation is weird. But yeah, it does work. It actually scales down our gateway servers. So just in theory, I could build a metric that I can already use. For example, I can build a metric that, let's say, we have instance dungeons, right? So for example, right now it's only the case for the first quest when you appear in the game. And they should host custom zones. So let's say I can define, I should have it somewhere in the dashboard actually, boulder zone. No, not zone. It's on the world level, I think. Zone instances. Why has it jumped to 50? I don't know. But yeah, basically, no, it's not this metric. It's actually on the zone server level. It should be zones create. I think I didn't add it to the dashboard. Oh, registered zones. There it is. So I can look at this metric. And here the dungeons host 8 zone instances, right? Why do we have 2 of each? I think there is something wrong with the dashboard. I would have to take a look. But yeah, if we say that a dungeon server should host on average like 20 zones, like, right? So one zone dungeon server should host on average 20 zones. We can create a metric that looks into that, and it creates new zone server instances if that amount increases. The question is, what would happen if there are already users connected to a zone server that gets downscaled and removed from the replica set? But okay, at least now I can do that and experiment with that. What's going on here? 589 milliseconds. Oh, I guess that was during that hiccup when my monitor went crazy. What? Something broke. I don't know. But yeah, this actually works. And I think this is... Oh, now we have just one. And I'm still in the game, which means it actually scaled down the server that didn't have connections. Which is interesting. It should somehow know about that. I don't know how that works, how that's supposed to work. But yeah, this is interesting. We can play with that. I don't need it right now, but in the future, maybe. At least now we actually have the metrics that we can work with. So, okay, I think this is gonna be it for today, because in less than half an hour, we have a movie session on Discord, and I need to prepare a little bit. So, let's see, can we rate somebody? Like, I keep searching for developers here on Twitch that work on the backend in Kubernetes, but I don't see any. Oh, maybe. They have a Kubernetes in their tags, but they are not working on it right now. But sure, let's go say hi. So yeah, this is gonna be it for today. Today, what did we do? We finished with the metric scraping. It actually works. All the metrics are now ended up in Prometheus. We even managed to make the dashboards work, even though they're weird. I need to double check what's going on there. But yeah, Kibana dashboards are working. And we did test autoscaling. So we managed to put metrics from Prometheus into Kubernetes, and now Kubernetes can actually use these metrics, and we can use them to configure pod autoscaler, which is good. I'm not gonna use this right now because, well, maybe we can do some more testing and see, like, for example, how does it work when users are connected to an instance that it tries to downscale. But yeah, that's for later. So yeah, I'm not sure if I'm gonna be streaming tomorrow. We will see. Please not this song. Oh no, I can't skip it. But yeah, thank you everyone for watching. I hope to see you next time, and bye-bye. Let's go raid this person.